Hello, this is a recording for cisp310 in fall 2018. This is for question number 3 of the final exam. So here's question number 3. It is supposed to be should be fairly short with this one because we have 4 parameters that we need to push on the stack in 3 separate calls. Okay, so the sequencing is kind of important. So let me point out what is important with this one. So what we need to do is to figure out that there are 3 calls to find max, but at any particular time we are only making 1 call. So this would be the first call to implement. This is going to be the second call to implement, and as these 2 calls are done, the return value should be pushed on the stack, so that by the time we have both of these done, then we can call this one with the proper parameters already pushed on the stack. And the important part is we have to push the second parameter first and then the first parameter. And also the other important part is accessing the parameters can be tricky as we have additional items on the stack. So so those are the things that I'll be looking for, as well as the deallocation of parameters afterwards, and also the saving of the return value on the stack. Alright, so let's go ahead and implement this code here. Okay, so let me see if I can. Okay, so we'll see whether there's enough room here to implement the entire thing. Alright, so let's go ahead, and this is find max 4, and it has no local variables. I'm just looking at the oh, there we go. So let's do one more time. This is find max 4, and what we want to do is to have offsets to the parameters. Basically we have w, x, y, z, and also the return address. So there are several ways to do it. One way to do it is to say return address is at offset of 0, and then we have w being run after return address, and then x is 1 after w, y is 1 after x, and then z is 1 after y. So obviously, whether you want to do it this way or not, or just say w is 1, x is 2, and so on, that's entirely up to you. But I need to be able to see somehow how to get to the parameters that are pushed on the stack. Alright, so we need to handle the push z and then y for z and then y on the stack. So so we can do it LDI A with Z, add AD LDA A, decrement D, and then STDA. That's going to push parameter Z on the stack, and then we'll follow this by pushing parameter y on the stack. So it's about the same thing, but it's not entirely the same thing because of this decrement D. So register D, the stack pointer, is actually pointing 1 byte below the return address at this point. So everything is now off by 1. So when we load A this time, it's going to be y1 plus to offset that byte that is pushed on the stack. Then the rest is about the same. So add AD LDAA, decrement D again, and then STDA. A. So this is pushing two items on the stack. We're pushing Z and then Y on the stack, and we're ready for the first call to find max. So now we'll go ahead and implement our first call to find max. So we have LDI A dot 6 plus. This is the return address. Decrement D STDA, which is our we are pushing the return address. Then we have a JMPI to find max2. And then when we get back here at this point, we have to increment the stack pointer twice because the two parameters are no longer in use on the stack. So at this point, the stack pointer is back to where the stack pointer was pointing to. In other words, it's pointing to return address again, but we need to decrement it again because we have to store the return value on the stack. Otherwise, we're going to lose find max2 of YZ. So that's why we need to store register A back on the stack. And now everything is off by 1 again on the stack. So when we need to push X and W on the stack, they will be off by at least this one. Okay, so now we go ahead and do LDI A X 1 plus. Okay, so this 1 plus is important. Add AD LD A decrement D STDA. So that would push X on the stack. Let's see, do I have enough room to push Y? I think so. Okay, so now we need to push W on the stack. LDI A and W is going to be 2 bytes off because the pushed X is also using 1 additional byte. So W is now 2 bytes off from where it was supposed to be relative to the stack pointer. So we need to add 2 to it. And then the rest is about the same. Add AD LD A decrement D and then STDA. So that pushes X and W on the stack, and now we are ready to set up the second call to find max2. So we have LDIA dot 6 plus decrement D and STDA that pushes the return address on the stack, and then we have a JMPI to find max2. And when we get back, once again, we need to increment D twice, and then we decrement it once to push the return value of this find max2 on the stack. So now we need to do a STDA so that we push the return value of find max2 WX on the stack. So now we have both parameters of the last find max2 on the stack. So it's time to call find max the third time. So LDIA dot 6 plus decrement D STDA and then JMPI find max2. And when this comes back, we need another increment D and another increment D so that we deallocate the 2 parameters of the third time of calling find max2. So the stack pointer should now be completely balanced, and it's time for the last few instructions to return to the caller of find max4. So that part is LDB. Cannot use A because A already has the return value of the third call of find max2. So now we load B with whatever D points to, which is supposed to be the return address. Increment D to deallocate that, and then a JMPB to return to the caller. All right. So this is kind of one way to implement this program. They are not the only way, but it's probably the easiest way to kind of keep track of everything. So let me point out what is important from the grading perspective. Okay, so from the grading perspective, there are some blocks of code that I totally expect to see, and so they're not going to have a whole lot of point values. So I expect to see 3 blocks like this, because these are basically calls to fxq3. By themselves, they're not really worth a lot of points, because that has been done to death. Okay, there are many places where you can just copy and paste that code. The same thing applies to the return code here. So these are fairly low point value kind of code, so I'm not going to put a lot of value into those. So the more tricky ones, okay, the more tricky ones are the ones where I can see that you're pushing arguments in the right order. So we can see that Z is pushed before Y. We can see that X is pushed before W. So the ordering is important. And then, of course, also important is when we decrement the stack pointer, the offset, the label which is representing the offset of a particular parameter from where the stack pointer points to, is now further away. So that means these items here are particularly important as well, because they show me that you understand that the stack pointer itself can move because we're pushing additional items on the stack. So when you need to calculate the address of parameters on the stack, you need to adjust for that. Oh, by the way, the green part would also include typical sequences like this, where we put the label into the register, which is the offset from where the stack pointer points to, and then we add the stack pointer to the offset to get to the actual address of the parameter. And of course, then we have the LDAA, because otherwise A is really just the address of the parameter, not the parameter itself. But this is also fairly low point value. And let's see. I would say in a yellow range, which is kind of like, kind of important, but not super duper important, is how we clean up after each call, like that. Okay, and you can see that they are the same, because every time you call fxq3, it takes 2 arguments on the stack, and as a result, it's going to need 2 increment D in order to displace that. Of the same importance as the orange stuff is that after the return from the first and the second fxq3, we have to remember to push the return value on the stack. So these 2 are important, okay, because they show me that you understand that the return value of the first call of findmax and the return value of the second time we call findmax, those return values are by themselves parameters, and you understand how to push those on the stack to set up for the third call to findmax2. All right, so that's kind of how I will set up the grading scheme for this particular question in the final exam. I will update you again with another video when it's time to do that.